Under this heading, we're going to talk about the various reactions that can happen, the fact that reactions in biology or microbiology are reversible, and the energy that are in chemical reactions. Let's talk about the various reactions. Say, for example, we have molecule A or atom A combining with atom B. Now that's probably pretty abstract. Let's talk about hydrogen gas being combined, and we'll call that A, and have B be oxygen gas. And if we combine those to make water, that would be considered anabolism, okay? Or putting two atoms, in this case 3 atoms, or molecules together. Okay, so anytime you take two different things, combine them together to make one bigger thing, that's anabolism. And that requires energy. Believe it or not, to make water out of hydrogen gas and oxygen gas, it takes energy and usually involves an explosion. Now, say we're taking something and we're breaking it apart. Okay, say we take water and we break it apart into oxygen and hydrogen gas again. Although that's not a really good example. We will have far more examples later. That is called catabolism. Think of it as catastrophic. Taking something bigger, like a building, and breaking it into smaller parts, the bricks of the building. Catabolism releases energy. And then there are the situations where we have two molecules and we switch the parts. For example, in this situation we have molecule AB and we have molecule CD, and we switch the B's and the D's to get AD and CB. That would be called an exchange reaction. Okay. Now, most reactions are reversible. So, say for example, that with molecule A and B, when we put them together to make AB, we can turn around and move it back. Okay. Most chemical reactions in cells are reversible. Inorganic reactions, usually they're not reversible, not unless you put a whole lot of energy into it. Now, let's also talk about some terms that you're going to need later. On this side of the reaction, we call these let's call these reactants. We have the two molecules that are going to be reacting. We put them together to make the product. Now you'll notice that if we're going this direction, this would be the reactant, these would be the products. Now let's talk about energy. Energy is the ability to affect change. Oftentimes we refer to it as the ability to do work. Kinetic energy is something we're familiar with. If you're running along, you're exhibiting kinetic energy. You're using the motion of your muscles to move you along. Or let's go with an inorganic example. If there is a boulder rolling down a hill, then it has kinetic energy. Now, before it started rolling down the hill, when it was at the top of the hill, it had potential energy. It had the potential to do work. Now, once it gets to the bottom of the hill, it stops and has potential energy again, but it has less potential energy than it had at the top of the hill. Chemical reactions are like that boulder. You can start out a reaction with lots of energy, go through the reaction, release energy, and have less energy at the bottom or at the end of the reaction. Now, we often graph this like this, where we have time at the bottom, we have the energy at the top, we have the reactants at the beginning and the products at the end, and you can see that in this case the reactants after the reaction released this much energy and we have less energy at the bottom. This type of reaction we would call exergonic. Okay. Now you'll notice that I skipped the hump here. It takes energy to break covalent bonds. Remember, those atoms are sharing electrons, and they don't want to stop sharing electrons. You have to put energy into the system to get the atoms far enough apart that they are no longer sharing those electrons. We call this the energy of activation. Okay, now we'll be talking about this later when we talk about enzymes because they lower the activation energy. Okay. Now what if we were to go the other direction? What if we were to take molecules down here, smaller molecules, and we put them together to make a bigger molecule that has energy stored in it? We've added this much energy. That would be considered an endergonic reaction. Now, from the reactions that we talked about in the previous slide, which ones would be exergonic? Okay. Those would be the catabolic reactions. Those that are endergonic or require energy are the anabolic reactions. Alright, that's enough for this part of the chapter. Remember, I'm doing this PowerPoint in two parts. For part 2, we will be discussing water and organic molecules. Now remember, you have a quiz to take at the end of this PowerPoint.